Electric network elements. Principle of combined power production. In this video, we'll talk about the principle of combined power production. At the end of this module, you will be able to understand how heat and electricity is co-generated at a combined heat and power production. Combined heat and power production, commonly referred to as CHP, and also known as cogeneration, is the concurrent production of electricity or mechanical power and useful thermal energy from a single source of primary energy. This is usually done by capturing heat that would otherwise be wasted in the form of steam or hot water that can be used for space heating, cooling, domestic hot water, and other industrial processes. Because of this, CHP-type power plants are usually built at facilities where there is a need for both electricity and thermal energy. Nearly 2/3 of the primary energy used by conventional electricity generation is wasted in the form of heat discharged into the atmosphere. Additional energy is also wasted during the distribution of electricity to end users that convert this electricity to heat. By capturing and using the heat that would otherwise be wasted and by avoiding electricity distribution losses, CHPs are able to achieve efficiencies that are in excess of 80%. Two of the most common CHP types today are making use of either a combustion turbine or engine and using a steam boiler with a steam turbine. Combustion turbine or engine type CHP systems burn fuel, natural gas, oil or biogas to turn generators to produce electricity and use heat recovery devices to capture the heat from the turbine or engine. This heat is converted into useful thermal energy, usually in the form of steam or hot water. For capturing the residual energy, a heat recovery steam generator, also known as HRSG, is used. It is a steam boiler that makes use of hot exhaust gases from the gas turbines or reciprocating engines. With steam turbines, the process begins by producing steam in the boiler. The steam is then used to turn a turbine to run a generator to produce electricity. After passing through the steam turbine, the steam has a lower pressure and temperature and can then be used to produce useful thermal energy that would otherwise be sent to cooling towers or would be cooled down by other means. For combined heat and power production to be practical, power generation and end use of heat must be in relatively close proximity. Even though the efficiency of a small distributed electrical generator may be lower than a large central power plant, the use of its waste heat for local heating and cooling can result in an overall use of the primary fuel supply as great as 80%. This provides substantial financial and environmental benefits. Thanks for watching.